This is lesson 10, and we will be talking in this lesson about how to use row operations to solve a system of equations. Can you hear my dog in the background? She's saying hello. So we have been talking this week about how we can use matrices in order to solve systems of equations. And the important thing we learned is that when we have a matrix, it's super handy to have this row of ones across the diagonal and zeros below that. This makes it really easy to solve for a single variable. But we won't always be given matrices that look like this. And so we need to manipulate our matrices a little bit in order to get it to look like this. This is called row echelon form. And in order to get a matrix into row echelon form, we will be using something called row operations. So row operations can be performed on a matrix, and these row operations look like addition, multiplication by a constant, and interchanging rows. Performing row operations on a matrix is the method we use for solving a system of equations. In order to solve the system, we want to convert our matrix into row echelon form. This is where there are ones down the main diagonal on the left side from the upper left corner to the lower right corner, and zeros and everywhere below that. So again, we want our matrix to look like this. This is what these guidelines help us to know what our row echelon form should look like. So our first non-zero number in every row should be a 1, and this is called a leading one. Any all zero rows, if we were to have a row of all zeros, they should be placed at the bottom of the matrix. Any leading one is below and to the right of a previous leading one. This helps us to get it into that diagonal. And any column containing a leading one has zeros in all positions before the leading one. So this is just a summary as to what our row echelon form should look like. But how do we get a matrix that's not in row echelon form into row echelon form? Well, we have 3 things that we can do in order to make this happen. The first one is we can interchange rows. We can swap 2 rows with each other. We can also multiply a row by a constant, by a number. And we can add the product of a row multiplied by a constant to another row. This might be a little bit confusing, but we're going to do an example that will hopefully clear it up. So our goal is to obtain row echelon form by using these row operations and then work backwards using substitution to find our solution. This process is called Gaussian elimination. Gauss was a mathematician way back a long time ago who worked in this kind of field, so that's why we call it Gaussian elimination. And again, the goal is to solve our matrix for our system, for our solution to the system of linear equations. So let's do an example. We want to solve this system using the Gaussian elimination process. I have negative x plus 2y equals negative 3, and 4x minus 5y equals 6. So first, my first step is to write the augmented matrix. So my augmented matrix will look like negative 1, 4, 2, negative 5, our vertical line, negative 3, and 6. My next step is that I want this entry, a sub 1, 1, to be equal to 1. Now remember, I can either exchange 2 rows with each other, multiply a row by a constant, or add 2 rows together. So I'm going to do this by, the easiest way here is just to multiply row 1 by negative 1. And doing this will make our first entry positive 1. Of course, it will also change the other entries in that row, but that's all right. So if I multiply row 1 by negative 1, I get 1, negative 2, 3, and then my other row stays the same, 4, negative 5, 6. Next, I want this element to be 0 in order to get that diagonal of 1s across the middle. So this is a little bit tricky, but I am going to do the following. I am going to add negative 4 times the top row to the bottom row. So basically, I am going to multiply the top row by -4, and then I'm going to add that to the bottom row in order to make that 4 turn into a 0. So we're going to go through this pretty slowly. So first, my first row stays the same. So I have 1, -2, and 3. And then I have 4 here, and I'm adding to it -4 times the first row. So this will be plus -4 times this entry, which is 1. Here, I will have -5 plus -4 times the first row, -2. And then I have 6 plus -4 times the first row. And when I simplify this, I get 1, -2, 3. 4 plus 4, -4 times 1 is 0. That was our goal. We wanted a 0 right here. -5 plus -4 times -2. That's the same thing as -5 plus 8, which is 3. And then I have 6 plus -4 times 3, or 6 minus 12, which is -6. Lastly, my final step is to turn this entry into a 1. And to do that, I'm going to divide this row by 3, or multiply by 1/3. This is the same as multiplying by 1/3. So that gives me, my first row stays the same, 1, -2, 3, 0, 1, -2. Now we have row echelon form. I have this diagonal of 1s and I have 0s below that. Now I can write down my new system of equations. So my system of equations will look like x minus 2y equals 3 and y equals -2. And now I can use substitution to solve for x and y. Well, I've already solved for y. I already have this one. So I can plug this value into my y here to solve for x. So x minus 2y equals 3. That gives me x minus 2 times y, which is -2, equals 3. Or x plus 4 equals 3, which gives me x equals -1. So my solution here is -1, -2. And if we wanted to check our work, we could plug the solution into our original system of equations. So let's go ahead and do that. So we're going to check our work. So my first equation was -x plus 2y equals -3. Well, -x is 1 plus 2y, that's plus 2 times -2 is equal to -3. That is 1 minus 4 equals -3, which is right. Our second equation is 4x minus 5y equals 6. 4x is 4 times -1 minus 5 times -2 equals 6. Well, this is -4 plus 10 equals 6. And that is true as well. So I know that for many of us, this is the first time we've seen something like Gaussian elimination. There will be lots of examples of this on your online homework, but please don't hesitate to reach out on the discussion board with any questions you may have about this. But that's it for today. So yeah, let me know if you have any questions on this, and have a great weekend. I will see you on Monday.